Okay, now I should have a microphone. Okay, let's make sure this isn't too loud. Let's show my face. This is what I get for starting without my mic or my webcam plugged in. But hey, everyone, how's it going? This is the second of the weekly updates. I'm trying really hard not to commit. Let me go. Let's go full screen. Face to cam. Hello. How's it going? It's been a week. I had a lot of fun sharing progress on stuff last week, and it's Friday again, so I've got a drink happy weekend, and I figured I'd bring you up to date with how the week has been going. So, my levels are kind of spicy. Let's make them a little less spicy. Little less spicy. Okay, how about that? Okay, I can live with that. I guess let me know in chat if it's miserable to listen to. But hey, everyone. Yeah, so I've had a week. Actually, at the end of last weekend, I was really excited because I got some stuff wired up. I had I got some stuff built. I got my power adapter built. I had my device on a board. And I actually booted it up for the first time. And I flashed some code to it. And I was doing some testing on LEDs. And I had those fancy LEDs that I talked about. These fun little fairy light looking guys. And those were working, and it was great. And then I wanted to see what the current usage was of these, because I've never used this, and it's like 10 meters of LEDs and like 10 LEDs a meter. So it's like 100 LEDs or something like that. So I wanted to see what the power usage was on this whole strip, so I was messing around with that. Turns out the answer is about 2 amps. If you have all of the LEDs on, it uses just around 2 amps at 5 volts, which was reasonable. It's on the high side for this, but you're also probably not going to have all of the lights on bright white all the time. So it was pretty reasonable. But then I decided to unplug some stuff and try and hook in my multimeter to figure out what my current usage was and stuff like that. And something I did cooked the board. I don't know if I shorted something with my multimeter pins or just the rapid unplugging and plugging while I left the LEDs on at 2 amps, which was probably a bad idea. The best guess that I have is that something made the buck regulator unhappy, and instead of putting out 5 volts, it put out something between 5 volts and 20 volts, maybe 20 volts, and all the rest of the electronics on the board do not like that. So now when I plug it in, nothing works, and the 3 volt rail, instead of being 3 volts, is 1.2 volts, which is not that. So I've probably cooked something. No actual smoke came out, but yeah, I'm chalking that one up to don't abuse cheap parts. And the DC converter that does the 20 volts to 5 volt is a very cheap AliExpress part. They look sort of like this. They are itty bitty. Again, I'm probably going to have focus problems, but you can see that they are, in fact, itty bitty. And they're like, I don't know, like 70, 80 cents a piece. So it's not a super quality, highly robust part. And I probably just cooked it. So that was frustrating because it was all ready to go and I put a lot of effort into that and then I couldn't do anything with it. So that was the start of my week, or I guess the end of my weekend, was very disappointing because I cooked the one device that I had. But on the plus side, I know that I wired up my programming lines correctly because I was able to program them. I know that generally my level shifting hardware works because I was able to drive both a little LED strip and a much larger, much bigger LED strip. And it was working totally fine, not getting too hot at what was, turns out, about 2 amps of current. So all in all, not a terrible failure. Set me back a couple days, and I really wanted to be doing things like making sure that the serial port communication worked, which I can't do with a cooked board. But what I have done now is I spent some time yesterday. Tell you what, let me put it back here and let me pull up the picture because I have some pictures of what I did, and that'll be easier than trying to haul this all up onto my actual... No, do not open this with GIMP. Just open it up with image preview. Oh no. Yes, thank you, GIMP. I went ahead and started building more of them because I think that's all I can do right now. So I went ahead and last night I felt inspired and decided to just go and build the power supply side of things. So that board's broken up into 2 parts. There's the green board, which has the Nordic radio on it. That's basically the brain. And then there's these black boards, which are on the bottom, which have the 20-volt power supply. And those little chips over on the left here are the RS-485 transceivers. So they came mostly pre-assembled. I had to put the regulators on there, so it's like solder them in, and then they're variable, so I had to set them down to 5 volts, which you can see I hit, within 1% or so. And then I actually tested the daisy chaining first, and this is actually a little thing over here. I have another picture of this. I'll bring that up in a second. But this is taking 20-volt power from this USB-C supply up here. This cable's running down here over on the left, and it plugs in over here. This is putting 20 volts over the Ethernet cable, wiring it up here. And you can actually see it daisy chaining to all the different boards. So that's working correctly. And I'm actually measuring this 5 volts all the way over here on the right. So each of these are dropping the 20 volts down to 5 volts. So the actual voltage along these Ethernet cables is 20 volts. And everything seems to work, which is nice. So that took a couple hours last night of assembly. I also move this down here and find the other picture that I want to show. Here. So this is actually from when I built everything on Sunday. These are the different components of my first one. This is the board that sadly died. But there's a couple things going on here. I have these like STMF4 black pill boards and a breakout that I made. And I'm just using it as a debugger because what I'm going to end up doing is putting 4 of these together as like a test rack, basically, and each of them will have their own debugger for now. I also have this little power injector, so that's a little Ethernet breakout board that I made just as like I use Ethernet cables for like everything. So you can see that on 3 of the 8 wires, the wires are connected to ground. On 3 of the wires out of the 8 wires, they're connected to VCC, which is 20 volts coming off this cable. And then the other 2 wires are for data, but I don't have those wired up anywhere here. And just a big blob of hot glue, and I treated myself to some fancy cable sleeving, so I made like a nice little cable where I've got the USB-C connector over here with some shrink wrap. I've got my shielding over here, and then some more shrink wrap, and a whole lot of hot glue holding that on and keeping things from getting shorted together. So this is basically my power injector for this. Luckily, I only need about one of these, and I didn't fry this when I was doing other stuff. So this is good. I've made 4 more of these, basically, and now, I guess this weekend I'm going to be building 4 more of these to start seeing whether the serial stuff works. And I guess maybe 3 more of these, because this is still fine. This didn't get fried. It's just everything that was on the 5-volt rail here seems to be cooked, including the 3-volt regulator, the Nordic device, and even some of the LEDs down here. So I did something that made this upset. So I'm going to have to deal with that. But, yep, lessons learned to be a little bit more slow-moving and careful, especially when connecting and disconnecting power supplies when you got 2 amps of load across the circuit. So that's most of the hardware update. It's just I need to build some more stuff and assemble some stuff. These boards luckily don't take a huge amount of time to assemble. They're mostly just installing all of these surface mount components, so like these capacitors, some LEDs and resistors, and then some resistors for the I2C pull-up. I'm still a little spicy on the level, so let me turn that down. Trying not to hit the red. Okay, I think that should be fine. So yeah, these don't take a huge amount of time to assemble. It'll probably take me another couple hours to build 4 of these. I'm not the fastest surface mount component builder at the moment. Even these ones didn't have a lot of stuff to assemble. Like all these surface mount stuff was already done. I was just assembling the headers and the regulator and then tuning the regulator and stuff like that. But yeah, it took some time. It's going to take some more time. We'll see how it goes. Yeah, that's a thing. But yeah, I figured I'd bring you up to date on that. Probably tonight I'm going to be doing a bunch more of assembly stuff. And yeah, I figured I could look at a little bit of the code that I didn't get to dig into too deep last week. I'll show off a little bit. Doesn't seem like there's too many people on this Friday, so, you know, I'll chat for a little bit. If you got questions, let me know for the couple of you that are in chat. But yeah, I'm excited and getting close to having a test bench. My real next goal is to have, like, I don't know, 3 of these hooked up, maybe 4 of these hooked up together. Be able to test that both of the RS-485 adapters work. Let's see. Yeah, here's kind of a close-up of that with my lovely hot melt. Here's kind of the end of that cable, and you can see I'm using Lego to hold everything together. And this is sort of a close-up of all of that stuff. Nothing, like, hugely mind-blowing here, but just some more stuff that I'm going to have to assemble. But yeah, I think that's it for the hardware updates. Yeah. So then I can look at some of the other stuff that's going on in this project. I guess I'll share a couple of the little things that I've been working on, and yeah. And maybe I'll have a short stream this week if there's not that many people. But I do like the fact, I do like, you know, sort of realigning myself going into the weekend, figuring out where I'm at, what I need to do. So I guess welcome to my stand-up meeting. But yeah, I think it'll be fun once the project is actually done if I have a couple of, like, periodic updates along the way. So something that I spent actually not that much time on, but has ended up making things really useful, is I do generally like to keep using all stable Rust, and right now using heap allocators in Rust are not currently stable. Well, you can use one, but you can't write one, which means unless you're getting one from the standard library, you can't define your own heap allocator. So this work has been basically making what's called a slab allocator, which is like a really much simplified version of a heap allocator in user space, more or less. Just treating it like it's any other library. So instead of having just like a global allocator like you might have in Rust, this instead is just a specific kind of allocator. And here, most of the time when I do allocations, there's really only one reason that I want to do allocations, and it's for buffers that I either receive off the network or I'm sending over the network. In the old school Anachro, I did everything without an allocator. I basically just had one queue coming in and one queue going out. And I managed to make that work, but the lifetimes on that were a nightmare. Because if you wanted to like hold on to a packet to retry later, it was just complicated and painful, and I'm sure it was very efficient, but it was not efficient for my time. So maybe someday I'll get back to that, but having something like this where I can basically just make an allocation, hold on to it for a little bit, and then give it up at some point is actually really nice. And I have this broken up into a couple pieces where essentially I have my own version of a box or like an owned allocation. And what this ends up being is just a chunk of bytes. Like it's literally just an array of bytes. So I might have like 512 byte chunks or something like that, which means every packet could be up to 512 bytes on the wire. Then I can deserialize messages from this, hold on to them for a little bit, maybe deserialize another part of the message, hold on to that for a while, and then eventually when I send it out over the wire, I can send it from that, and then once I'm done processing a packet, I can just let it go, and it gets recycled. And as opposed to regular allocators where if you run out of allocation space, you just panic, here all of my allocations are basically failable, which means they return an option, I think. So when you say, I would like to allocate, you get back an option. So you will either get a sum box or a none. And this is also nice because when I'm passing around this packet around my code, this is just a reference. So this is 32 bits and then an index, which is 32 bits. So I'm really only passing around 8 bytes, which means that instead of having to like copy data around to different function calls, I'm only copying around a pointer and a slice, basically. But the nice thing about this is you can have a box, which is an owned item, which means when it gets dropped, it automatically gets deallocated, but you pass it around with ownership. But I also have the ability to turn that box into an arc, or a reference-counted data structure, which means I can actually hand out different views of the same data, and the memory actually won't get deallocated until everyone's done with it. So if you're used to using like an arc or heap allocations in general in Rust, this works more or less exactly the same way. But this one is nice because it's using my allocator. I can even borrow a chunk. So an arc borrows the whole 512 bytes, but let's say I've deserialized a message and realized I only need 30 bytes or something like that. I can just hold on to that view, or I could have multiple parts of my code that are each holding on to a different part of the same message. For example, if they were deserializing different parts of the message, and they can all hold on to them as long as they like, which seems really straightforward and easy, but well, actually, like the code for it isn't that complicated, but it's one of those simple little things that makes coding the network stack way easier because I don't have to worry about lifetimes nearly as often, and as long as I don't accidentally end up holding on to this data for a long time, it's pretty much just the same as before, sometimes even more efficient because I may be able to directly send from that original buffer. For example, if I'm forwarding a message, which means that I don't have to copy the data from the input queue to the output queue. So this might even make a couple things faster, which is nice. But the code on this is actually really easy. The way that I do allocations, instead of like going and looking for where a free space is, what I do is on the beginning, you tell me how many slots you want to have or how many slabs. So you might say, I want to have 128 slots, each that are 512 bytes. And when you create this, all it does is actually, where's my initialize function? Inside of this data structure, it has the big buffer of bytes. So if you had 128 times 512, it's, excuse me, that many bytes. I have basically which slots are there. So if I have 128 slots, I have an array of 128 slots. And then I actually just use a queue, like a first in, first out queue, to hold all of the allocations in it. And what I do is I just push each slab into this queue. So it's basically just a queue of what index do we have. So this might take a couple, maybe a kilobyte or something like that to track all of this. But it means that allocating is really easy because all I have to do is pop the front item from the queue, and if there's anything in the queue, then that's a free item, and I'll just use that. And then when, for example, the box gets dropped, all it does is it pushes itself back into the queue. So that's how it drops itself, is it just pushes itself back into the queue, and because this is a thread-safe queue, it's totally fine to do that. And that means that it just shows up, and more or less how many items are in my queue or how many free pages that I have. There's probably a more efficient and less overhead way to do this, and I will probably do it in a smarter way at some point in the future, or maybe even do it in a way that allows me to... Right now, if you have an arc of just 32 bytes, you're still technically holding on to the full 512 bytes. But that doesn't necessarily have to be true. I've written some proof of concepts for a slightly smarter allocator that I might switch over to at some point. It's a little more complicated, so I haven't written it yet, but it'll probably end up being more efficient. But hey, we'll see. I'm not currently blocked on that yet. So this very simple and efficient enough sort of thing is working for me. So all that demo, if you didn't see the video last week, I did a demo of that working last week, and yeah, that's exactly how that's working. Okay. Well, that's the allocator. That's a big part of it. And then in the rest of the network stack, I use those really heavily. So one of the things that I showed off last week was like the discovery process. And like I mentioned that this is all async, and it basically just works on, you allocate a packet, you try and receive, or you allocate a buffer, you try and receive a packet into that buffer, you process that. Does that queue have a len operation? No, Jay Clifford, that does not. The npmc queue in heapless doesn't expose a length operation, I think because it would end up being a little racy, in terms of like, by the time you've checked it, it could have changed. So it doesn't expose one. I could probably keep track of my own counting variable to tell me like how many free pages that I have, but at the moment I'm just not worrying about it. But the npmc queue from heapless does not have a length or basically like a current capacity. Well, I think it will tell you what the total capacity is, but it won't tell you how many items are in that queue, just because it is multi-threaded. So any number that you get could immediately fall out of sync. So it's not a super useful number to have, other than maybe as a heuristic. So I might end up making a version that does track that, and I'm just careful not to know, because if I all of a sudden say that I have 9 and I try and push 9 things in there, someone else could have pushed something else in there or popped items from the queue. So, no, it doesn't, but that's a good question. I've wanted that a couple times, but I've sort of convinced myself that it's a bad idea. But I'm just using the off-the-shelf heapless crate for that. So I think I talked a little bit about this async stuff, but a lot of this really helps out. I have this file called dispatch, which is more or less figuring out how I take messages that come in off the wire, how I route them to the correct port on the device, because I have sort of like TCP or UDP ports. I have a concept of both like your address and then ports, and I do certain things like, right now I think I'm using port 10 as my like management port. So like if you ping someone, or if you're looking to get an address assigned to you or assign an address somewhere, that all happens on port 10. and eventually I'll make other ports that do certain things, just because it makes the software a lot easier. But just being able to see the fact that it can hold on to certain buffers and stuff like that, and that it can hold on to its allocator in a static way. And for example, this IO queue, which is what's doing the shipping of messages from the dispatcher or like the routing part into the actual IO part. I can just have a queue of slabs, and I don't have to worry about lifetimes or anything like that, or sending messages. So sending things from dispatch to the IO, like when you're sending a packet out to the actual hardware, or when you're receiving a message from the actual hardware back to the routing chunk. I can just have like queues of either boxes or slabs and things like that. And I have some wrapper types here that do things like, it's a box and a timestamp of when the message came in. So if you're processing the messages later, you know the timestamp of when it was received, not when you're processing it and things like that. So I have a couple of these sort of wrapper types that I use them, but under the hood you can see that they're all either using a slab of data, or I have managed arc slab, B slab, and slab box. So slab box is an owned one. B slab is the actual allocator, and managed arc slab is this type that I have. I think actually in the slab. Yeah. So this is really similar. There's a crate in Rust called Managed. It's written by Whitecork for the small TCP stack. And it's really nice because sometimes when you're sending messages, you don't necessarily need to allocate a box for that, because if you're sending it immediately and doing something like serializing it to a message or something like that, or deserializing it from a message, sometimes you just need a slice, and it's okay to have lifetimes. So sometimes this is nice to avoid doing extra allocations when you only need one of these packets for just a short amount of time. So I use these in a couple places. They're handy for avoiding like allocations when I don't need them. But yeah, a lot of it is really just carrying around those and shuffling those around from one part of the software to another. And then all the logic is up here in the DOM and the sub stuff. And they're more or less just using this. Let me go show you in the dispatch of the kind of interface that you get. Because the idea is that you would make one dispatch item. Basically, it's a singleton. It sits at the top of the code, and you can actually make it at static context. If I look at the my example code, well, I'm doing this in threads because I'm making multiple devices. For one device, you should only need to do this. But essentially, I'm putting these in boxes, but you could make them static in terms of a... let me see. I think I had notes somewhere. Layout thoughts. Yeah, the idea is to do something like this, where you have just like the allocator that sits at the top of your program. You have the IO queue, which is doing the messaging back and forth from the actual hardware that's sending and receiving data. So this is your like low-level IO. And then your dispatcher. And then my dispatcher is basically doing the routing to all the different ports and services and stuff like that. And the way this actually ends up looking is that each dispatch, you can register a port. So sort of at the beginning of your program, you can say like, I would like to allocate port 10. And it says, great, you have now a socket. And this socket that you're holding on to gives you a handle to basically send or receive data. So for most like pieces of logic or services or tasks or whatever you want to call them, they're just going to have the socket that's relevant to them, and they don't need to have to worry about any of the I/O stuff. You have sort of like the same way that you have a TCP socket or a UDP socket. You're just occasionally either sending or receiving a packet. And that way they don't think about, timing of the serial port or anything like that. They just have a queue of packets that they send and receive. And that makes things really handy, like we can see in the Discover stuff when we're like when we're doing pinging of the readies. What I do is I basically make up the payload of the message. I allocate a new port for this with the payload, the source and destination address, and then I just try and send the message. And then I can also sit here and receive with timeout from my socket in an async way and basically wait for a message to come in off the socket. And if something comes in, I can process it. And this way also, if a different message comes in, like to a different port, I never even see that. So it's not like I have to filter only messages that are relevant to me. I only have to listen to my own socket, which means, you know, if you're used to working with UDP ports and stuff like that, it's going to feel really familiar because that's basically exactly the process that I'm stealing. But yeah, the ability to have this on a very low power device with relatively low overhead and to be able to handle messages fairly quickly and efficiently without a full networking stack, just a little bit of like packet queues basically, is really nice. And yeah, I'm looking forward to actually testing it on hardware once I unfry my hardware. But yeah, this is the next step really, is to get a couple of these devices together on physical hardware and set up on like a test bench basically, because it all works in the simulator now. And now I need to see if I actually wrote my simulator correctly and whether I actually wired up all of my serial ports or like these RS-485 bus connections, and to see whether I can really bring up the interface, enumerate all the devices on here, and have them all just send messages back to each other. So I'll probably end up connecting some multicolor LEDs to each of them and have them pick random colors for each other and send each other messages that they should change their LED's color, and see if they listen to each other and if everything goes well. And if that works, then what I'll probably do is send off an order for more hardware, because I'm planning on making about 10 or 20 of these, all told. So I guess I'll order at least 15 more, and yeah, go from there. But that's about where I'm at. I need to assemble some more hardware so I can test the software. I'm really trying to avoid writing custom software just to test the hardware, because that's hopefully a waste of time. If everything doesn't work out of the box, then I'm going to have to write some more custom hardware and hook up a logic analyzer or something to see why it's not working. But yeah, like I said, my hope is that this works out of the box and I just get a green light on everything and it all works. But yeah, I think that's all I really want to share. Like I said, I got derailed for about a week. Didn't get to do much. I have some more ideas on stuff that I would want to put outside of this, you know, like what kind of control panels I want and temperature sensors and stuff like that. But I really need to get the actual bus going first and then try them out over like longer lengths as well, because these are little 1/2 meter cables that I have. But really prove out the fact that I can hook them up with you know, maybe like 100 meters of cable. My apartment is not 100 meters big, but, you know, run around the outside perimeter of my apartment and see how it works. See if it's noisy, see if they drop a lot of packets, see if they get confused and they lock up after working for a couple days. But yeah, the idea would be to just have a bunch of these, and maybe every couple minutes they just blink a random color so I know that they're still alive. And yeah, make sure that my hardware isn't dying in fun and interesting ways, other than hopefully this first one, which only died because I was being a little silly with it. So I think that's mostly all I wanted to share. I'll probably do what I did last week. I'll go ahead and I'll drop out for like 5 minutes, drink my drink, keep an eye on chat. So I think there's only 1 or 2 people in chat. So if you have any more questions, feel free to ask them. Otherwise, excuse me, have an excellent weekend. Hope you enjoyed the second update, and I'll probably keep doing this sometime on Friday afternoons. It's a fun way to start the weekend and figure out if I want to do some hobby stuff, what I'm going to do. So as long as I have time and I'm not overstressed, I'll probably keep doing this. But yeah, I'll drop out for a couple minutes. If people ask questions, cool, I'll come back and answer them. Otherwise, have an excellent weekend, and catch you all next week. So I'll put the music back on and see you in a couple minutes if you have questions.
growing obsolete. Obsolescence feels complete. I'll turn off all the lights and I'll close all the windows. My desktop is clear and I'm out of here. My cache is blasted, a thing of the past. It's
Hey, J. Clifford. So I think we just had one question, so I'll probably go ahead and wrap up here. But J. Clifford's asking if this is up on GitHub, and the answer is yes. I have to check whether I've pushed it lately, but let me pull up this. I think my current code is up. I probably will post the hardware design files too. I've just been lazy about that. But I don't mind them being open source because I've really showed them. It's not well commented, I will give you that. So it is up here. I've put together the, and I'll drop this in chat too, and probably link it in the description. But yeah, it's in chat. Like I said, it's not well commented. It's hobby project fun stuff, so don't take any of it as best practices, and I'm likely to break everything fairly often. But the interesting parts are here. Anachro 485 is sort of the 485 networking stack. Byte Slab is the allocator that I spent most of the time talking about today. And Sim 485 is sort of the... I've taken the Anachro 485 library and made it run on the desktop here. It's not a great simulator, it's a pretty simple one, but it's useful for getting logic going. And then soon I'll probably have a NRF 52 485 here, where I have sort of the low-level drivers implemented for the 485 stuff and all of the the stuff like how long do you wait before calling a message received and stuff like that there. So all this stuff is in there. I'll keep it updated. I'm mostly doing this for fun, so apologies if it's not well documented. But if anyone has any questions, feel free to send me a mention on Twitter. I'm always happy to chat, or just ask questions in the Q&A, and I'm happy to answer them, and eventually I'll write docs. But right now I'm just having fun doing ridiculous things, and I'm sort of tearing down. I think in the last, one of the last merge commits that I did, I ended up rewriting, like, the difference between when I changed how I did my networking stuff. I ended up rewriting half the crate. So there's definitely been some pretty radical changes here. It's not a ton of code, but yeah, when I switched over to the old way of doing I.O. to my newer way of I.O. that I just explained, I rewrote like the whole thing. So I haven't been good at documenting stuff, but once it solidifies a bit and I have something that works, you know, fingers crossed for docs. But yeah, great question. Feel free to ask anything there. I'll probably put the I've got this Anachro RS repo here, so I'll probably make a new GitHub repo just for the hardware design files for both of these two boards, and at least the pinouts and stuff for the other stuff. But I don't expect anyone to reasonably be able to use this yet, nor do I know if it totally works. So I'm not too worried about not posting it there. I also moved the old Anachro repo, the one that's more focused on the building a little PC in Rust. So this was all the stuff that was demonstrated in my Rust Lab talk last year. So all of that stuff is now here. Eventually, like I said, I'll tie this together with the 485 stuff, but right now this is kind of my working repo of all of the current hardware stuff that I'm doing. But I think that wraps it up for me for a Friday, I guess. I'm going to start soldering. So I guess follow me on Twitter if you want to see the progress pictures on that. Otherwise, I will see you all next week when I do another quick update. So thanks everyone for watching, and I hope you have a great weekend.
Thank you.